Hey all, so we're going to start looking at chapter 5, and this is going to start going into integrals and area under the curve. So the first thing that we're going to talk about is estimating area under the curve with Riemann sums. One of the things that you're going to see that is maybe different in this class, this is what I found in the past, than in your previous classes, is one thing that the AP will do is that they will not only ask you to write and calculate Riemann sums, these rectangular approximations for the area under the curve. Right here we have a left-hand Riemann sum, and then we have the right, depending on which corner of the rectangle we're using. But you'll also be asked to recognize it in a sum form. So I'm going to quick go over that. So if we're doing the left-hand Riemann sum, so in this case, you're going to start with this big blue rectangle that we see here. And it's a rectangle, so it's got a length, which is b to a, b minus a, divided into n rectangles. So you're going to do b minus a over n times the height of the rectangle, which would be f of a. The next one, in this case, has the same height, and that would be f of a plus that rectangle's length. So then we get down here, and so on. This rectangle, and on, until you end up at the end. Now, these all have the same width of rectangles, so you can factor that out as b minus a here, leaving behind a series of the values of the function, which you can write as a series like this. And so you'll often see this as a very standard AP type question, where they'll ask you, okay, here is an integral. Now, what am I going to, what would it look like in series? Because remember, the integral is equal to the Riemann sum as we start having more and more n, or as n approaches infinity. Now, the key to recognizing this is you want to make sure that your b minus a makes sense and is the same for both. So that's the best way. They're generally multiple choice questions, and you just want to be checking those fractions. They should match both here and make sure that they match the range in that problem. And then, of course, make sure that the function is the same for both. If this one's x squared and this is x to the third, for example, that's the other thing you want to check. Now, using Riemann sums, you estimate the area under the curve from 1 to 2 using a left Riemann sum where n equals 4. So the first thing that I'm going to do is I am going to calculate my b minus a over n. So that's the width of the rectangle. And that's going to be, in this case, 2 minus 1 over 4, or 1/4. So what I'm going to do is, in order to find the values of the function, I'm just going to make a little table here where I have my x values and my y values, and those are the ones that you use as your height. So then I start at 1, 1 1/4, not 2 yet, 1 1/2, 1 3/4, and 2. So then the height, using our formula, x squared, that's the height of the graph of the curve. So then I have 25 over 16, 9 over 4, 49 over 16, and 4. Now, it doesn't specify right or left, so we're going to do both. The left Riemann sum, as we talked about here, always starts at a. So our a value is 1, so our left Riemann sum, r sub L, is going to equal the 1/4, that width of each rectangle, times the first one, plus 25 over 16, plus 9 over 4, plus 49 over 16. And so we only go up to that because that's the left bound, as you can imagine, then 4 would be the right bound. So the left Riemann sum is going to be 1.969. If we did the right Riemann sum, that still has the width 1/4, but we're starting at the right bound, which in this case is 25/16 for the first one, 9/4 for the second, 49/16 for the third rectangle, and 4 for the final one, which means that the right Riemann sum is 2.719. Now, one thing that's super helpful here is you might get asked, okay, well, estimate what the integral is going to be. Well, we know that the integral, the actual value, is in between the right and left. So as you can see here, we have an overestimate with the blue and an underestimate with the red. So in this case, the integral is going to be in between 1.969 and 2.719. You're also going to be asked to estimate Riemann sums and integrals with tables, and the important thing with the table here is that unlike this problem, your rectangles are not going to all be the same size. So in this case, I'm just going to do them separately, and it says with the left, so that means that we're going to start here. This is the left-hand bound of our first rectangle, and that rectangle's width is 5. So my first rectangle is a 5 by 17. The next one is going from 5 to 12. So instead of that, 5, this one has a length of 7 and a height of 21. The next goes from 12 to 15, so that would be 3 times 24. And then the last one goes from 15 to 20, which would be 5 and has a height of 32. Now, this is the area under the speed curve, so this will give us distance. And when we add these all up, we get 464. Now, I would hope that you would notice if I asked you for a distance and this vehicle or object is going 17 to 31 miles an hour, it's not going to cover 464 miles in 20 minutes. That should make you feel weird about your answer. And that's because you always want to be thinking about the units. Because when we multiply these together, the time is measured in minutes and the speed is in miles per hour. So this is the unit we currently have, which is a very weird unit to use. And that's because the minutes and hours aren't going to cancel out. So what you want to do to get a final answer is multiply by the conversion factor so that you can cancel out the minute in the denominator and the hour in the numerator, and you'll end up with miles as the unit you want in your final answer. Now the numbers in your conversion factor are 1 hour to 60 minutes. And so your answer is going to be 464 over 60 miles, which is equal to 7.733 miles. I'm going to check that on my calculator really quick because that doesn't seem right, but it's what I've written in the notes. So 464 divided by 60. Okay, yep. All right, I was wrong. That looks great. And this would be your correct final answer. So make sure you're paying attention to your units. If you have any questions, please let me know. Either make a Zoom appointment or you can check in looking at for videos about homework, put your nominations in that form, put anything in the comments. Talk to you later.